Good morning, students. Today we are going to start some more questions revision about the different chapters which are coming in the exam or daily examination. The first question is from complex number. Express z equals to 1 plus I root 3 in polar form. So z is equals to 1 plus I root 3, which is written as r cos theta plus I sin theta in polar form, as the polar coordinate is r and theta. This is our equation number 1. Now 1 plus I root 3, open the bracket, r cos theta plus I r sin theta. When we compare the real and the real part, imaginary and the imaginary part, both the sides, on comparing real and imaginary part, what we have, r cos theta is equals to 1 and r sin theta is equals to root 3. That is our equation number 2 and 3. Now to get the value of r, we will square both the sides of equation 1, 2 and 3 and we will solve it. So on squaring equation 2 and 3 and adding them. So r square cos square theta plus r square sin square theta, 1 का square 1, root 3 का square 3, r square common, cos square theta plus sin square theta is equals to 1 plus 3, 4, cos square theta plus sin square theta is 1, 4, so r will be equals to square root of 4 plus 2. As the modulus is always positive, so we will not take here negative value, we will take always the positive value. Now on dividing equation 3 with equation 2, what we have, r sin theta upon r cos theta is equals to root 3 by 1. That becomes tan theta is equals to root 3, and root 3 comes in tan pi by 3 degree, tan 60 degree. So our argument theta will be equals to here pi by 3. So we got the value of r and the value of theta. That value will substitute in equation number 1. So therefore z is equals to 1 plus I root 3 equals to r value is 2 cos pi by 3 plus I sin theta value pi by 3. So this is the polar form of a complex number, z equals to 1 plus I root 3. Now let's move to the question number 2. Question number 2. Find the real number x and y if x minus iy. Since it is given that x minus iy into 3 plus 5i is the conjugate of minus 6 minus 24i. So I'll put one bar for its conjugate in the next step. So 3 into x, 3x plus I into 5x minus I into 3y and minus 5yi square equals to conjugate of this. We'll change the imaginary part sign. Only the imaginary part you have to change the sign, minus a plus, and real number sign will be as such. So 3x plus I we can take common from here, 5x minus 3y and minus, this will become plus 5y equal to minus 6 plus 24i. As we know that I square is equals to minus 1, therefore it become plus 1. Now our real part is 3x plus 5y plus imaginary part 5x minus 3y equal to minus 6 plus 24i. Now we compare the real part to real part, imaginary part to imaginary part. So on comparing real and imaginary part. We have 3x plus 5y equal to minus 6 and 5x minus 3y equals to 24. Now we have to solve these two equations. We multiply this equation with 3 and this equation we multiply with 5 to eliminate a variable y. So 3 into 3 9x plus 15y equals to minus 18 and 25x minus 15y 24 into 5 that will be equals to 120. Cancel out. This will be 34x is equals to 102. So x will be equals to 102 upon 34 which is equals to 3. Now from any of the equation 5x minus 3y equals to 24. Value of x we got 3. So 5 into 3 minus 3y equals to 24. That is 15 minus 3y equals to 24. Minus 3y equals to 24 minus 15. Minus 3y equals to 9. Y equals to minus 3. So these are the two values. X equals to 3 and y equals to minus 3. Okay. Let's move to the next question. That is our article from the permutation and combination. So NCR question number 3. LHS we can take NCR plus NCR minus 1. As we know the formula NCR is factorial n upon factorial r factorial n minus r. So we will apply here the formula factorial n factorial r factorial n minus r plus factorial n upon factorial r minus 1. In place of r it is r minus 1 and n minus r sign will change plus 1. Now factorial n upon this can factorial r can written as r into factorial r minus 1 factorial n minus r factorial n factorial r minus 1. This n minus r plus 1 can be written as n minus r plus 1 factorial n minus r. So factorial n factorial r minus 1 factorial n minus r we can take common in the next step. So factorial n upon factorial r minus 1 factorial n minus r taken common, we are left out with 1 by r plus 1 upon n minus r plus 1. So factorial n upon factorial r minus 1 factorial n minus r. We now take LCM, the product of both the denominators. So here in the numerator n minus r plus 1 plus r. So plus r and minus r cancel out. Now this n plus 1 can be got first n plus 1 factorial n. This r factorial r minus 1 and this one n minus r plus 1 into factorial n minus r. If you think in the reverse direction, this complete two terms can be written as factorial n plus 1. If we break n plus 1, we will get n plus 1 factorial n and factorial r minus 1 in the reverse direction can be written as factorial r. N minus r plus 1 factorial n minus r can be written in the reverse direction n minus r plus 1, which is equals to n plus 1 CR, and that is our RHS. And this is the most important article question. Okay. Now we come to the question number 4. Question number 4 is, if A, B, C are in AP, since A, B, C are in AP, when the three numbers are in AP means middle one will be equals to sum of the first and the last divided by 2. That is B equals to A plus C by 2. And B, C, D are in GP. Since B, C, D are in GP, when they are in geometric progression, middle one's square equals to product of the first and the last number. C square equals to B into D. Now next is 1 by C, 1 by D. 1 by C, 1 by D, 1 by E are in AP. When they are in AP means again the same thing. 1 by D will be equals to 1 by C plus 1 by E upon 2. When we simplify this, we get D equals to 2 times of C E upon C plus E. Equation number 3. Okay. Now we have to show that A, C, E are in GP. So if A, C, E are in GP, then square of this must be equals to product of these two, AE. Then only we can say that A, C, E are in GP. So C square we are having, B also we are having, D also we are having. From equation 1, 2 and 3. 1, 2 and 3. C square equals to value of B is our A plus C by 2 and value of D is our 2CE upon C plus E. So value of B and D substituted in equation number 2. One of the C can be cancelled out. This 2 and this 2 I can cancel out. C plus E can be multiplied to the left side cross multiplication C, and this A plus C right side we are left out with only E. Now open the bracket. C square plus CE is equals to AE plus CE. Similar terms, both the sides cancel out. So we get C square equals to AE. So when we got C square equals to AE, it means that we can show that ACE are in now GP. Correct? So ABC are in AP, D equals to A plus C by 2, BCD are in GP, C square equal to BD. 1 by C, 1 by D, 1 by E are in AP means 1 by D middle one will be equal to sum of the first and the last divided by 2. After simplification, the value of D we will get it as 2CE upon C plus E. So this value of B and D will substitute in equation number 2 and we will simplify it and we will get C square equals to AE. Therefore, ACE are in GP. Let's move to the next question. Question number 5. The sum of three numbers in AP. Three numbers in AP are A minus D, A plus D. Last 10th also you have studied this. And their product is 440. First we think about their sum. Their sum is 24. So A minus D plus A plus A plus D is equals to 24. So plus D minus D, 3A equals to 24 implies A first term we get 8. Now their product is 440. Their product is 440. Let us see their product. A minus D, A plus D is equals to 440. Substitute the value of A, 8 minus D, 8 plus D is equals to 440. So 8 minus D into 8 plus D, 64 minus D square upon 440 divided by 8. This 8 will come down. So 64 minus D square equals to 8 4s are 8 5s are 40 and 40 again, 8 5s are 40. Their product is given 440. Yes. So A is 8 minus D, 64 minus D square. 8 5s are 40, 8 5s are 40. It is 55. Now minus D square equals to 55 minus 64. Minus D square is equals to minus 9. D square equals to 9. So D is equals to plus minus 3. So if we are having, if A is equals to 8 and D is equals to, we are getting first one 3. Our numbers A minus D, A and A plus D will be 8 minus 3, 5, 8, and this will become 8 plus 3 11. And if second case, if a equals to 8 and d equals to minus 3, then a minus d, a and a plus d, just reverse the numbers 11, 8 and 5. So these are the numbers when the sum of the three consecutive numbers is given 24 in AP and the product is given 440. When we add up, we get the value of the first term, and with the value of the first term, with this help, we can calculate the value of d, and d value is two values of d are there, plus 3 and minus 3. So for both the cases of d, we have to get the value of these three numbers, a minus d, a and a plus d. Now let's come to this last question. Which of the following sequence, the given sequence is 2 root 2 4 dash 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 is 128. That is, we have to find out the n, the number of terms. First term a to common ratio, second term divided by first term, 2 root 2 divided by 2, that is root 2, and the last term is 128, and n we have to calculate. Since we know that L equals to AR to the power n minus 1, last term 128, first term 2, R is root 2 to the power n minus 1. 128 by 2, 64, root 2 to the power n minus 1. It will be root 2 का base लेंगे यहाँ पे root 2 का power 12, because root 2 to root 2 is 2 and 2 to the power 6 is 64. So root to the power double 12 will be 64 and root 2 to the power n minus 1. Since the base are now same, their powers can be comparable. 12 equals to n minus 1, therefore n equals to 13. This value of n will be never negative and never in the fractional form. Okay? So these 5 days revision, and every day I am going on sending you the through broadcast channel some of the few of the MCQ questions as well as the subjective questions. Work hard, try to get good marks. I know that you will work hard and you will study and you will score 100% marks in half yearly examination, and some of the formulas related to all the chapters which are coming in the examination, half yearly examination, I will be sending you in the PDF, in Saturday's PDF. Please study well and try to score 100% of marks. Best of luck for all your examination. Thank you.